All right, next up, we have this terminal side thing with a coordinate given. So the first thing is that we have to draw the dot. So we have 8 comma negative 15. So think about this is 8. This is negative 15. So approximately right here. Now the biggest struggle for some students is that do you know how to draw your reference triangle? Your reference triangle should be like this. So you connect the dot to the origin, and then you would draw the triangle this way. The base side of the triangle must be on the x-axis. Okay, think about how this is actually the way we measure our reference angle, and this is what we call our reference triangle. So think about why they all have the word reference. Well, because the way we actually do our drawing would be the same. So what you can do here is that you can say, oh, this length it's 8, this length it's negative 15, and so what is this length right here? Okay, so you have 225, which is 15 square. Okay, plus 64, which is 8 square. Okay, then you have 289, and 289 is the square root of 289. It's 17. So you have 17. I think this is one of the Pythagorean triple. It appeared on your quiz, I believe. Okay, so now it's in quadrant 4. So what I usually do is this. I would actually put the signs up. I know that there are some signs I know for sure. The negatives are for sine and tangent because of A, S, T, C. So if it's quadrant 4, then cosine and secant will be positive, and the other ones will be negative. And at this point, I just need to make sure that my ratios are done properly. For example, cosine theta, it's 8 over 17. So secant theta would just be the reciprocal of it. And then sine theta, it's negative 15 over 17. And then cosecant is just the reciprocal of that. And then tangent, it's negative 15 over 8. And then cotangent would be negative 8 over 15. So if you draw your triangle properly, you label your theta properly, there is absolutely no chance that you can get it wrong. Absolutely no chance you can get it wrong. Okay, so fairly simple. Okay, and if you have a number like 289, you should know that it is a perfect square number, and you can simplify it to 17. It would not be acceptable that you put down square root of 289 as part of your answer. Okay, now number 8 is somewhat similar, except that the information given it's slightly different. Now it tells you that the sine theta it's negative, and cosine theta it's also negative, and that indicates, well, in order for both to be negative, it must be in quadrant 3, and there's a fraction right here. The fraction is 2 over 5. That means the ratio of the opposite over hypotenuse will be 2 over 5. So think about that is the that's away, and that's negative 2 because it's going down. It's a negative y-axis, and this is the theta. Okay, this is the theta, and then the missing x value. Okay, the missing x value, or the length, the base side of the triangle on the x-axis will be, what is it, 25 minus 4, so it's just 21. So negative square root of 21, okay? So negative square root of 21. Now, so for this type of question, you should, well, the moment you see a square root, you should be on the lookout that you probably will need to perform some level of rationalization. Okay, so we have now at the same time, I would like to put my sign up first. Okay, So tangent will be positive, but everything else will be negative. So cosine theta, it's negative 21 over 5. And then I would have secant theta as 5 over root 21, which is equal to 5 root 21 over 21 with a negative sign up front. Sine theta will be negative 2 over 5. And then cosecant theta would be 5 over negative 2. And then tangent theta would be negative 2 over negative root 21, which makes it positive. Of course, positive. And then you rationalize it. So you have 2 root 21 over 21. And cotangent is just root 21 over 2. Okay? So again, make sure you know how to interpret the information that it is telling you the angle is in quadrant 3 indirectly. And once you obtain the information, find out the missing side using Pythagorean theorem. Simple, easy.